Hi, everybody. Welcome to the August 22nd webinar. We've got John and Alex today going to talk about IaC security, which is kind of fun. I think that for all the webcasts we've done this year, I believe that this is the one with the most acronyms in one set of slides that I've ever seen. And what we've tried to do is just to give you lots of good information, but I am a little disappointed in Alex and John that when I reviewed the slides, I did not see a single acronym that they had made up just to mess with you. Because I personally think that would have been awesome. Like just have, like you have an entire slide deck and then like just way one, right? Yeah. Okay. Make me a BLT ASAP. Yes. Stat. And so I really think this is something I've encouraged for years at conferences and courses that have a vendor area, is that you go to the vendor area and you make up an acronym, but you say it with confidence. Like, you just like you walk up to the vendor and you say, okay, I know you guys are doing machine learning and all that kind of stuff, but how do you handle the BLT of the system? And then just see how long and how many vendors you can get through before one of them says, I have no idea what a BLT is in this context, right? Like just, I enjoy doing it. Earlier this year, I got to do that at RSA. It was the best RSA I've ever had because of that. It's just a fun thing to do. But having said that, how about I turn this over to the actual experts? John and Alex, I look forward to hearing what you guys have to say about IaC. So thank you.
Now you're in my head.
Yeah, I know.
If we hadn't uploaded these static slides, I would have added one real quick.
Here's the best part. I just gave you guys an excuse. If you misstate an acronym, you can just pretend that was the one you made up. Look, I'm helping you out here. Cool. I'm going to mute myself because nobody wants to hear me talk.
All right. Well, yeah, I'll go ahead and I'll kick it off. So got the title slide here. We'll just get this out of the way. Hopefully you all know you're in the right place. This is the flight to Atlanta. No, this is the webinar for Code to Cloud. The idea behind this is to give you some idea of how to strengthen your infrastructure as code by using, or the security of your infrastructure as code by using the SAST tool sets, SAST frameworks. So let me introduce myself. I'm John Knepp. I'm one of the senior security consultants at Secure Ideas here. I've been with Secure Ideas since 2020. I was originally in Denver at the time I joined. I've since moved to the Salt Lake City, Utah area. I happen to bear the distinction of the consultant who lives furthest west in Secure Ideas. And that means I'm also 2 hours behind most of my colleagues. So I just finished up lunch just before I jumped on. My history is I was an IT admin and architect for, I used to say 20 plus years. I kind of did the count. It was 25 years before I switched over to Secure Ideas and started doing cybersecurity full time. So I've been in a wide range of companies, different sizes, from like a 30, 40 person, well, even smaller than that, but I don't really want to count those. 34, 40 person shop, all the way up to large multinational with tens of thousands of employees. Covering oil and gas, healthcare, financial, and big data. So seen a lot in my time, saw a lot of different kind of contextual areas, things that would impact the way that you make business decisions, the types of things that businesses are going to value and need to protect. So it gives me a good range of perspectives to apply as I'm servicing the various customers. Then on a personal note, I'm an aspiring home brewer. That's what I do with my free time. I'm also a dad who's trying to get the last of my sons to leave the nest. And I'm slowly replacing each of my sons with dogs. as they've stopped giving me the attention and love that I need, as they've grown older and decided to turn their attentions elsewhere, I've had to replace them with dogs.
Nice.
So.
Awesome.
Move it over to you.
That sounds good. Hi, I'm Alex Rodriguez. I'm a security consultant, operations person, and general development person. I do pretty much infrastructure things for secure ideas, help deploy them on-prem and in our cloud, and also develop some applications that run on them, help the operations of secure ideas kind of run. So through my various responsibilities, I've toyed with Linux, Ansible, Bash, Python, containers, Terraform, and Kubernetes. So pretty much a bunch of different Linuxy and eventually security stuff within that experience. Otherwise, I like to listen to a lot of podcasts, and I enjoy contributing to open source. So I think we can move on to the next slide.
You want me to handle that?
Sure. There you go. Awesome. So we're going to kind of outline what exactly the presentation is going to cover. What exactly is IaC, or infrastructure as code? What exactly is static application security testing, or SAST? Then we're going to kind of, once we have that base level definition, kind of go over what it looks like to have SAST integrated with IaC. That first outlines the reason why SAST is important, which is the common pitfalls of using IaC. And then how we can leverage SAST to kind of help join them together and kind of build on top of one another. After that will be a live demo where we'll kind of demonstrate how simple it can be. Of course, it's always contextual to your environment, so I'm not going to say it's a simple process completely. But afterwards, we'll cover kind of a practical way that you can approach integrating SAST into using IaC. And then open the floor for questions.
Yep. All right. So infrastructure as code. And I'll kind of state, I spent a good bit of my career managing infrastructure at a large organizations, small organizations. Since I joined Secure Ideas, I put that aside, right? I've actually not really been involved at all with infrastructure management here at Secure Ideas at all. That's all Alex. So really, he's going to play the role of like the subject matter expert today. And I'm going to provide that historical context because that's really where that's what I did. That's where my perspective is that historical context. I will say that having kind of come up and spent the bulk of my career pre-infrastructure as code, this first column on this slide, this is where I lived for most of my career. You're running commands, you're working through documentation and guides for your configuration of your environment that are hopefully documented and written out. And, people are trying to follow those steps and reproduce kind of the standards that you set forth. The goal, of course, being consistency and repeatability. And, if you start off and you've just got people doing all those steps, you need to rely more heavily on those instructions, like the configuration instructions. Then we moved on to scripts and other kind of automation tools to help you provision those systems and install the software and set the configurations. So that was the traditional server provisioning model. And some of that could be extended to other portions of the infrastructure as well. Some of network configuration can be scripted. That's the traditional model. That's what a lot of us came up with and what we understand. Infrastructure as code came out and it kind of opened the realm of possibilities. It was something that really really came to the forefront with things like Azure and AWS and the cloud. So I'll let Alex introduce the next part, but that's where we started from. And infrastructure as code is answering a lot of those age-old challenges that we had.
Yeah, absolutely. Yeah, it really kind of came to boon with the more DevOps kind of momentum, where there were more clouds and APIs accessible and available. The nice thing is that there's actually been kind of more of a movement to integrating infrastructure as code on-prem as well, which has been a really enjoyable experience to see. So just kind of high level, what is infrastructure as code? I'll give you the definition by Wikipedia standpoint real quick, just to kind of give like a base level. This is what people typically see it as. So that's infrastructure as code is the process of managing and provisioning computer data center resources through machine readable definition files rather than physical hardware configuration or interactive configuration tools. So what does that mean? Because that's a nice jumble of words, but essentially you are defining what your infrastructure should look like in text readable files. And then those files are your code for what your actual infrastructure can get deployed from. So whenever I say code, there's two different types of that. There's actual programming code that has kind of been more of a newer evolution of infrastructure as code. And then there are other tools that use what are called a DSL, or a domain-specific language, to format exactly like in a more approachable way. They format how you can describe your code. So those are kind of two of the different types of code that infrastructure as code can refer to. And then this next part kind of addresses initially the couple of iterations for infrastructure as code had a more imperative perspective. And imperative means that you essentially are kind of taking like more of a script methodology, where you're outlining your instructions and it executes those in line. These were a bit more robust than just regular bash scripts or something like that, because you can enable, like for example, you can use Ansible to kind of scale that type of execution to lots of servers. But it's kind of more of an imperative approach, which is more the declarative approach is kind of you outline what you want and then the tool executes it for you. And I think John had mentioned to me before that this is kind of like the holy grail.
Yeah, if you look at the evolution, and I don't want to say that there aren't some elements of declarative kind of definition or declarative controls for your traditional hardware model, like, well, not hardware necessarily, but the traditional server provisioning, because PowerShell tried to do some of that. And there's some other tools that'll do that as well. But, as Alex was saying, initially infrastructure as code sort of looked at the evolution of the script model, which is basically, hey, go do this step and then this step and then this step and do it in this order and follow this path. And went more towards the declarative that basically says, this is the end state. This is this desired state. Configure it this way. So that declarative model where we're just like, the reason why why scripting and automating was so difficult was because you had to think through all the steps and define all the steps to get from the blank slate to that final product. Whereas what you really wanted and what you were building toward was, this is the final state I want to be in. Give me this final state. And that, then you're letting something else take the hard work out of that, of getting to that final state. If you want a setting to be set a particular way, you want a particular piece of software to be present in a particular state at that finished end, that's what you're defining with a declarative process. That imperative was kind of sort of the starting point, but not ultimately what we were trying to get to. So infrastructure as code kind of evolved from that traditional model towards really that ultimate declaration of what we want. Sorry to reuse that word, but that's the goal, right? Is to take that uncertainty of, there's too many ways to kind of achieve that goal. At the end, all that matters is, did you get to the state that you want to be at? So
yeah, absolutely. Yeah, and that kind of also that methodology kind of stemmed the more modern and containerized tools of like Kubernetes and other things like orchestration and Google's Borg project. I mean, I'm sure that they probably had internal Google tools that were doing some things like Kubernetes beforehand, but just kind of that same thought process. And then I think this third column, who is infrastructure as code made for? So I think John is going to take more of the sysadmin perspective here, and I'll cover the other.
Sure. I mean, that I just kind of mentioned it. The idea here is that system administrators, let's be honest. One of the big challenges, and I said it before, is consistency and repeatability, right? When you've got a team of administrators that are responsible for spinning up servers, provisioning servers upon request, each one of them might have a different process, right, for that. They may be not as familiar with some of the steps, or they may have different ways of achieving the same goal. And those variances and human error can result in kind of variances in the end result. So this was, again, that holy grail of being able to come up with a process that allowed you to eliminate that human error and allowed you to get like that ultimate consistency and repeatability, because the machine is simply going to deliver the same, like input in, results out, matches the same time. It doesn't get tired. It doesn't have lapses of attention. It doesn't need, it's never going to miss a step because it's not human. So system administrators, for at least solving the problem that we've struggled with to achieve the results, infrastructure as code kind of ticks all those boxes.
Yeah, absolutely. And like I mentioned before, the DevOps movement was kind of a big proponent of the infrastructure as code in general, because they were more moving towards how can you integrate developer methodology of being able to code various problems and issues into this operational problem. So tools like HashiCorp's Packer and Terraform, those are a few examples of some of the more early DevOps tools that I had experience with. And then transition to, like I said, going all the way kind of to the Kubernetes level, where it's a continuously reconciling system. So the DevOps people were kind of the big driving proponent, and then security from a blue team actually is able to start integrating that kind of shift left methodology of where you're actually working with the devs to try and, okay, you're defining your infrastructure as code, but you might not be following best practices for defining that code and defining that infrastructure. So allowing the security team to kind of integrate in an earlier cycle in the dev, SDLC, or software development lifecycle, allows, I should have came up with a different acronym there and just mess with people like Kevin said. Allows them to work in earlier into the process. And actually on the converse side, the red team is actually also able to utilize this to accelerate their already fast operations that they have. So I actually did a webinar last month of how I was able to use infrastructure as code to kind of evade more of the blue team's traditional like thresholds for doing some enumeration and scanning of their systems externally. And so through that, I was able to kind of, at a fast pace, be able to spin up servers and spin down servers and evade their protections that they have in place.
So I think this highlights something, and what Alex said is really demonstrative of the fact that infrastructure as code, just like the app version of kind of that continuous integration, it's enabling, or it's kind of the offshoot or the evolution of that accelerated process that we have. Those development pipelines move very quickly. That's what drove forward the idea of needing to get infrastructure as code in, because it was in support of delivering kind of that, meeting the pace and for deployments for the development and those sort of application deployments. And then security had to come along for the ride as well, because everybody has these kind of shortened cycles. It's all being kind of pushed. All the work and all these kind of assessments and the testing and everything is kind of being crammed in earlier and earlier into the phase, to the point now where you're building it into the product and building it into that pipeline, and that agility is really, not only is it important to counter the fact that our adversaries are also equally able to capitalize on the agility and the speed of kind of shifting with infrastructure as code and being able to deploy things very quickly and spin up new infrastructure to attack us. Being able to adapt to that very quickly and to respond to that very quickly with infrastructure as code and making those changes and getting them pushed out as an integrated whole, it's necessary today to actually keep up with the capabilities that are out there, both on the blue side and the red side. So,
absolutely. And then this last column is just why.
Oh,
a fun meme. No, you're good. It's just a fun meme to. It is time.
Yes. Well, it's all about if you don't adapt, if you don't move forward to it, you're going to get overrun, because the capabilities are there, and your adversary is going to try and take advantage of that.
Absolutely.
Okay.
Awesome. Yeah. So this next slide kind of now that we spent quite a lot of time at that infrastructure as code level, but I think it's really important because it's the whole fundamental basis of why we're building on top of that. So now we're going to kind of talk about, from a higher level, what is static application security testing, or SAST. And this concept has actually been around for longer than just infrastructure as code. If you're new to the infrastructure, or if you're new to the security scene, this actually has been applied to generic application code in the past. And so OWASP kind of has a definition that they typically use for the actual application code. So what is SAST? And it can help analyze source code or compiled versions of code to help find security flaws. And so that's kind of a short synopsis as to what SAST does. And being able to apply that to infrastructure and security best practices is an amazing feat that we weren't able to accomplish before, because everything was manual. So there was no way for you to really analyze the actions that are going to be taken. It's only you'd have to analyze the actions that are taken from after they've already been executed. So that kind of falls into the actual implementation layer. Now, the one big kind of caveat between whenever you do SAST for applications and SAST for infrastructure as code is that you might find similar types of vulnerabilities, but they're not going to be the same. They're not going to be the exact same. So John and I were kind of talking about this before, to where you can kind of think of it as like almost different operating systems, to where say infrastructure as code is like a Mac, and then regular application SAST is like Windows. So you'll have similar flaws from the perspective of like a general class, but it's not going to be the exact one-to-one kind of thought as to how things can get implemented. Because these SAST tools for infrastructure as code are going to be more looking at it from a foundational and an infrastructure perspective, not you have SQLI in your application.
There's different tests. It's looking for different things. For auditing, I mean, SAST is essentially the infrastructure as code version of a manual audit and inspection of the settings and the software that's installed and the things that are in your registry, right? You have to go out and manually inspect those, or have a script that goes to manually inspect those. SAST is the framework that will actually do that for, in an automated fashion to check those states in an infrastructure as code scenario. And it's borrowing from the fact that this framework, this, I don't know if you call it a harness, testing harnesses, that kind of thing, from that application side. Now we're using it and applying it to something that's producing not an application, but actual infrastructure. So
yeah, absolutely. And it can really give you a lot more deeper insights than doing something like dynamic application security testing, from the perspective of it has the context of this variable is getting applied to this specific module for this tool. So it gets that more holistic picture of what your infrastructure looks like. And some of the benefits that you end up getting from this is that you can integrate it earlier into the life cycle, like we had talked about before with the whole shift left methodology. So it allows you to integrate tools to help augment your actual scanning and enumeration of possible vulnerabilities before it even actually gets deployed into production. So it allows you to kind of have that secondhand sanity check to make sure, hey, am I doing the best practice here? And it can also offer some either automatic resolution, so you can either apply like a flag or something like that, and it'll just automatically fix it. Which be careful of that because you always want to make sure you're testing it before you apply it and then deploy to prod. But it can sometimes offer those resolutions, as well as if it doesn't have an automatic resolution, it can give you a link out to more context as to why this is considered a bad practice. So kind of.
And from an infrastructure perspective, one of the other, when you look at where vulnerabilities will crop up in traditional infrastructure, you've got consistency, right? People were inconsistent about the way that they applied your standards and configured settings. You've got and then you've got drift, right? Over time, your standards might change as your standard build changes. The standards for what you consider your base build will change. And it can be time consuming to apply those changes, to retroactively go back and apply those changes. But with infrastructure as code and SAST, Alex is pointing out here, you can have it say, well, our new desired state is for this setting to be enforced on all of our systems. You make that change, you deploy it, and the through infrastructure as code, it goes back and it pushes that change. It essentially deploys that change across all your infrastructure, all your existing infrastructure that you've defined. You say, this is the state that we want the new normal to be, and it'll go back and it will fix that for you. It'll correct that setting or apply that setting change. So this is, again, back to imperative is, as you're doing it, this is how I want you to do it during the deployment. Declarative, which this is taking advantage of, is saying, this is the state we want everything to be in. And then it's going back and it's fixing anything that's not in that state. So powerful. All right. So there are, as glorious as it seems that everything would be, because now we've solved the problem of consistency and repetitive, repetition, and making sure things that address drift. The world is not, it's not all happiness and snuggly bunnies. There are still some things that you have to worry about, right? We can't get lazy just because there's tools that are doing some of these things for us. We still have to worry about some of the the pitfalls. Hard-coded credentials, right? Because you're defining this stuff. I mean, this was a problem with scripts before, right? I can tell you, even last week, I found a script on a share that had hard-coded credentials in it. Actually, it wasn't quite that bad. There were credentials that were easily decodable from, that were encrypted, but they had the key right there, so I could decrypt it. But again, this is about the practices. You have to watch out for things like hard-coded credentials and hard-coded secrets. Gee, I just fed right into that other one. The key was there too. So we have to be careful about kind of managing some of these things, making sure that we're not being careless with what we're including. There's a lot of abstraction in infrastructure as code that's both powerful and potentially dangerous, in that because the power is in just simply being able to change a bit of text in a file, you can impact the infrastructure as it's deployed. So you have to be careful to make sure that those things that are in those files are, number one, it's powerful. So, you're going to need to have permissions. So you need to make sure you're managing your secrets well, and you need to make sure that you're protecting that code as well from unauthorized changes. Where were we at? We're on insecure implementation and defaults. I think you can probably give them a little more insight into what you mean by that.
Yeah, absolutely. So generally, there are projects out there that have you curl pipe the bash. So while it is very convenient whenever you do something like that, sorry to clarify, not infrastructure as code things, general scripting like previous, using other people's scripts and other things like that. So whenever it comes to actually deploying things to your infrastructure, make sure that you're reviewing code that either you have used, when your colleague has created, or that if you're using other things like modules, like in Terraform, there's a registry with predefined modules for defining networking assets and other things like that, and servers. Make sure that you're understanding what's happening in that code, so that way, one, you're not using something that is someone else's code and then they put like a backdoor in it somehow. So that would be kind of the insecure implementation perspective. It also comes down to insecure implementation of whenever you use those, sometimes there are defaults that are not the most secure that they could be. So that's something that you need to be cognizant of, and just make sure that you're reviewing and understanding the options that are there. And then we'll cover this in a little bit, but you can utilize other tools to kind of help understand what those kind of insecure defaults are, or not following best practices.
I would kind of equate this to, from a traditional model, it's, Windows by default doesn't install to be secure by default. I mean, they're getting better, definitely, but there's always a need to do additional hardening, and it's situational, right? Not every, it's not one size fits all for hardening. Sometimes it needs to be softened depending upon what the business requirements are and the application's requirements. So sometimes you can't turn off all the services, right? But you want to reduce that attack surface. So it's kind of a similar thing here. You can't just assume that everything out of the box, you can just kind of stack all these pieces together and you're going to be secure. You still have to kind of be a little more introspective about what components you're piecing together, what their capabilities are by default, and what options maybe need to be tweaked as you're piecing them together. And what the potential for injecting unknown vulnerabilities into the environment. I mean, I think we'll talk a little bit later about the fact when you're using an off-the-shelf container, somebody's published a container in a repository out there, and you're deciding, well, I'm going to use this as the basis for part of my infrastructure as code that I'm standing up. But then there ends up being a flaw or a vulnerable component in that. You didn't deploy the vulnerable component. You just consumed a solution that was implementing or using that one. So you don't necessarily, this is kind of the bill of materials concept. You kind of have to look and see what's inside some of these things you're using to know whether or not an kind of an upstream vulnerability might be impacting you.
Yeah, absolutely. Yeah, and I think that that dovetail nicely into the whole best practices as well, because the upstream best practices that are being developed for these tools are still, since it's still more an emerging field, they're kind of always changing. The tools are making changes all the time, so they're putting out updates. So you need to be kind of cognizant of, if something does change, you need to make sure that you're understanding what the best practice for that actual implementation is. And that's kind of where SAST can also help you out with, because there's communities out there that are essentially trying to work and identify what are bad practices and kind of essentially codify or build them together, which can kind of lead us into what joining the two of these together kind of looks like. So you can kind of see that they're a symbiotic relationship. So you can utilize infrastructure as code to codify your infrastructure, and then you can actually leverage SAST to then make that infrastructure even more secure and leverage the best practices that these larger communities have created and companies are behind, and allows you to really build some very foundational and secure building blocks that you can then utilize and reuse in your infrastructure as code. So that allows it to scale that security to reusing modules, almost like from a function level, if you think of it as more of a development term. So you're taking that kind of function, making sure that you're doing all the security best practices in there, and then you're reusing that throughout your code. And that kind of highlights how you can utilize infrastructure as code in a not necessarily as good way as well, because this is whatever you make of it. So, for example, if you're trying to deploy two different VMs, you can always take a single VM, define it in infrastructure as code, and then you can create a whole nother separate infrastructure as code file, and that will define a VM again. And so instead of being able to define those two separate things, you can consider using like a module or a function, like I had briefly mentioned before, and then being able to reuse that functionality to deploy both those servers. And so that helps that scaling factor that we talked about. And that can even lead to essentially like a platform as well.
Yeah, because I painted that rosy picture of, oh, you know what? When you start using infrastructure as code, you don't have to worry about inconsistencies and drift. Yeah, but now we say, oh, well, I'm not deploying a carbon copy of this server anymore. Now I'm going to go over here. I'll kind of take this over here, and I'll make a different one. Well, you're splitting it apart, and now maybe you've got two different kind of standards that you're building off of. So now you begin to kind of get into this sprawl of, well, how many different versions of a server template do we have out here? Are we approaching these in different ways? Are all of our server templates consistent across the board in what the current security standard is? So there does need to be some, I think it's slightly different problem, or slightly different solution needs to be applied here, because it's no longer, about it's like the traditional server stand-up, but you still have to manage those kind of variant versions, the variants of the scripts to stand, or not scripts, the code to stand up your environments. You need to make sure that you kind of apply a governing tool, a governance over that to ensure that you've got a consistent approach across all of those things.
Yeah, absolutely. And whenever it comes to enabling your developers to develop tools or develop infrastructure for their applications, you can essentially bake in all of that security into a template that allows them to kind of, like I mentioned, kind of treat it more like a platform. And that allows them to also, if they're choosing an insecure default, or if they're choosing to add something of themselves on top of it, you can give them that kind of like localized feedback of before it even gets to you. You can integrate in something like CI or continuous integration or CD, continuous deployment, to make sure that it's doing those types of security checks before it even actually gets deployed to production. So you can
bake in the security into what they're allowed to use, so that you know what baseline they're starting from, instead of just letting them go out there Wild West and starting off with kind of the simplest blank slate that has no hardening in it whatsoever, and then having to port that into their solution after they've already started developing against it, right? Give them the pre-hardened solution to work from and let them build off that.
Exactly. Yeah, and you can even get even more localized to whenever they're actually developing their infrastructure as code. There are tools that you can have either right before they do a git push with a git commit hook. You can have it checked then, as well as in their actual IDE, it can highlight things as well. So that really helps enable the business to move faster, because they're able to get that faster feedback sooner, instead of having to wait for the security team to come around and review, or the infrastructure team to come around and review what changes they're implementing for their infrastructure, stuff like that.
This is really that whole concept of shifting left. You're baking in kind of the security and the design into the process, that development pipeline, so it becomes a part of it. It's integrated with it. It doesn't have to be bolted on afterwards as an afterthought, which is where all the kind of the stress and conflict comes in a lot of times, in that kind of the security, infrastructure, and development triad.
Absolutely. Awesome. Well, I think it is now demo time. So I am going to share my tab. Let's see. So I'm going to start out with showing you some of the details of what we're running first. This one. Okay. All right. Can you see that? Awesome. Okay.
I can. I guess I'm the only one that can actually say it out loud. So yeah,
that's fair. Hopefully this is a big enough size for everyone. This is a Docker file. This repository is actually open underneath our Professionally Evil organization. So the link for this is actually in the slides that I'll show later. But this Docker file is essentially going in and it's pulling in a few different infrastructure as code tools called TFSec, Terrascan, KubeAudit, and Chekhov. So TFSec is a Terraform security evaluation. Terrascan is another Terraform one. And then we've got KubeAudit, which is more of a Kubernetes evaluation, and then Chekhov, which kind of covers both. In this scenario, we're only going to cover running two of them, and you'll see that in this script. TFSec and KubeAudit are the two that we're going to be using. But those kind of tools are baked into that Docker image if you want to kind of explore more and see what exactly those outputs would look like and other things like that. So this script is getting copied into this container. And so we've got all the binaries bundled up into the container, and this script executes those two different SAST tools. So we can hop over to terminal. Ooh, sneak peek. And I'm going to go ahead and build the container and then run it.
Well, I'm not seeing your terminal.
That might help. Yes. Let me see if this makes a difference. All right. How about that? I'll just do my whole screen. Is that better?
Yeah. Nice white terminal.
Yeah. Typically, I don't like doing white. I'm just trying to make
it's great for screenshots.
Yeah, make it more readable. So we're gonna build the container first, and then once we build the container, we're gonna go ahead and run the container. And whenever we run the container, it's gonna do that entry point.sh that we had shown before. So it goes ahead, and because all of this is cached, it's actually very fast. For you, it'll take a little bit longer because it'll download things and stuff like that. So this is the actual output for the TFSec. It kind of highlights the different possible security issues, and this is one of the topics that we're going to kind of cover after the demo. Is some of these issues that it identifies, you have to kind of contextualize for yourself. So from my personal perspective, if you're using an application and it needs to pull updates and other things like that, and you don't want to have to constantly disable and re-enable egress traffic, then this rule might be okay for your organization. But this is calling out that it allows multiple internet access, or it allows multiple internet access to it. So it just kind of depends on your use case. But in this situation, this db-app.tf, this is a bit more critical from the perspective of this database is then exposed to the internet. And typically you want to keep those kind of more sensitive systems internal only. So that's kind of a best practice that I would definitely consider something that you should take into consideration and follow and adapt into your organization. There was one other one. So this was kind of the other one that we were talking about, where you're hard coding secrets. So to clarify, these two repositories that I'm running this against, they're intentionally vulnerable or insecurely defined environments. So they're called KubeGoat and TerraGoat, and they're kind of more bad practices not to do, and giving examples of that so that way you can kind of understand what not to do. So after it gives all of the different potential issues with their details, it also gives a timing and kind of just some stats about things that you'd want to consider or fix. And then we've got the Kubernetes results, and this is from the Kubernetes manifests or configuration files that actually deploy containers and such. One of the more really impactful ones is that, where's that? There we go. The run as non-root. This is the container is by default running as root. And so you want to make sure that you specify the configuration option of run as not root in the security context. So that way you're not allowing the application inside the container to have effectively root level permissions for the actual underlying OS as well. So this is kind of where, as more infrastructure as code things evolve and continue to develop, these best practices kind of change as there's more options and other things like that. So that's why having these SAST tools kind of helps enable you and kind of keeps you at the cutting edge of what are best security practices for your infrastructure as code tools.
So Alex, just going to ask the question. So here's me. I haven't ever written any sort of SAST rules. I haven't developed an infrastructure as code pipeline. And I'm looking at this and what you're showing me, and I'm thinking, I couldn't necessarily envision it before, but I'm thinking to myself, so really the SAST tool, all I have to tell the SAST tool is, hey, I'm going to run these kind of checking tools against what's in my pipeline for my infrastructure as code script to run. And it's going to come back with various alerts and errors. And I'm going to create my own threshold to say, if I see any errors that are above this threshold, I should stop with don't push the pipeline any further. Stop, throw some sort of alert to say, this needs attention. It needs to be addressed before we can go any further. Is that basically it? I'm just kind of setting my preferences to say, as long as these tools don't return any alerts, that I'm given this SAST run against the infrastructure as code to pass, and I can move on to the next step in my pipeline? Or is there more to it than that?
Yeah, that's something we will get into for the contextualizing for the organization, but you can definitely take that kind of blocking approach to where if they have some type of threshold of they have too many critical findings, or if they've increased their severity from last time to this time by a certain amount, then you can actually have the tool fail out. This is all going to be specific for the actual tools themselves and configuration options for that. The alternative approach that you can consider as well is that if you're just trying to start working on integrating SAST into your infrastructure as code, you can actually have it not be a blocker and just kind of throw out those actual notifications or errors, so that way the developers are aware of them before you actually start implementing it into a block mode.
So the short story here is SAST doesn't have to be a complex setup. It could be, just straightforward to start.
Yeah.
Doing these checks to see whether or not there are any alerts thrown up by the tools,
Absolutely.
and then build customization onto it from there as needed to kind of meet your organizational needs.
Absolutely. And you had mentioned pipeline briefly there. That's the other part of this demo, is that this is actually a GitHub action, and this YAML file is in the actual repository as well, so feel free to look at it. But as you can see, it's the same results. But what you can do is you can have it actually have an artifact. So it'll upload the results of that, and then you can integrate that into your workflow however you want to afterwards. So it can be a manual review process, or maybe you integrate it with more automation. But that way you kind of have that artifact of this is what happened for each of the builds or each of the CI/CD runs. So awesome. That is the demo. I think we can just do that.
And there's the slide you talked about.
Yes.
Links.
Exactly. Yeah, you can also consider, like I had mentioned briefly before, is that pre-commit hook. The other thing you could do is in VS Code, you can create a tasks.json to actually have predefined SAST runs or SAST configuration options. So those are just kind of some other options you can consider. Awesome. Awesome. So I think this is kind of what we were talking about. Now that we've talked about some of the kind of things to be considerate of and other amazing features that SAST and infrastructure as code offer together, you just kind of have to think about it from a more pragmatic or practical perspective, kind of like how John was asking me before, is how are we supposed to integrate this? So first off, it's going to depend how much you can influence your organization and how much you want to actually make these like blockers or other things like that. It really comes down to identifying how best to enable the business and also start to encode these kind of best practices and integrate them in various locations. So it allows your developers to integrate into security earlier. So we're doing that shift left with the CI/CD and locally with your IDE. Also helps encode best practices into your organization. We kind of briefly talked about that. And then one of the things that I briefly had mentioned with the actual tool that the first rule from the TFSec was that this idea of false positives or things that for me aren't necessarily important. So for example, I had an error or a notice that one of my buckets was openly permissive, but I'm the only one that owns the AWS account. So openly permissive for other people to access in the AWS account. So since there are no other people in that organization, that threat vector doesn't really apply to me. You want to really think about those kind of false positives for that.
Yeah, this is a good time to mention that while, and I've had a lot of kind of customers that I've dealt with who, you ask the question, as you're kind of doing an assessment of kind of their security practices. You say, do you have documentation for your processes? Do you have process documentation? Do you have documentation that kind of walks through what your build standards are? And of course, the people that use infrastructure as code, it's infrastructure as code. It is living documentation. It's the documentation. I'm going to point you back to where we were talking about imperative versus declarative, right? Infrastructure, even with the imperative, it's really about achieving, it's the steps. And then with declarative, it's the end state. But nowhere in here really is there a documentation of the intent. Why was it that way? Why that state? What were the reasons for making those choices? There's still a need to capture that as well. The SAST kind of does a little bit of that. Like your SAST design is going to be based on what's important, right? It's informed by the business, and kind of that context provided to it is your business context. You can't just take somebody else's SAST and apply it to yours and say, we're good, let's go to town, because you don't know whether or not they're the reason why they chose to test for those states or not to test for something aligns with your business needs and your business particulars. So don't skip out on kind of documenting that. Kind of capture those decisions, capture the reason why you're deciding that, hey, we're not going to block on an alarm that says this setting is overly permissive, right? Don't just whitelist it and say, well, that's not important, let's move on. Because if you then later on have somebody come along and read that and say, oh, well, they didn't care about it over here, so I guess we don't care about it. No, they didn't care about it over there because there was a specific business decision or reasoning behind that. Document that reasoning so that you don't just blindly follow when and apply that same setting when the business reasoning doesn't match.
Yeah, that's actually one of the nice things that some of these tools actually have is whenever you want to whitelist or allow list a specific issue or concern that the tool brings up, is you can actually add a comment right above where the actual thing is that you're trying to allow list. So that way you can give that business context that John is talking about right there. So that way whenever someone does review the code, they're like, oh, let's apply that. And then they see, oh, well, actually, they had this process that they went through, and maybe this is the person that approved their exception and other things like that. You can ingrain that information into your infrastructure as code.
Consider it part of your change control.
Absolutely.
Oh, and by the way, back up your infrastructure as code. And version control is always a good idea.
Absolutely. Yep. And then this last bullet here was the feedback from devs, and that's kind of more the shifting left and integrating your security as much as you can. Maybe like I had mentioned before, you kind of turn on this alerting or other things like that to start showing them what will happen, and then eventually you kind of hard enable these types of SAST tools to start actually being blockers. So that way they're getting that feedback before actually having that agonizing process of being blocked.
And don't forget that the ultimate driver here is enabling the business, right? Enabling the agility that's the business. That's really what the business is pushing for. Development needs to do this not just because they want to be a thorn in the side of infrastructure and be combative. They need to do it because they have a mandate from the business to deliver a product or to support whatever the case might be. Infrastructure is there to support and enable and facilitate the delivery of that product and the support of that product. And security is there to make sure that all those guys are considering the risk to the business and managing that risk appropriately. All of this, all of these steps, all of the implementation of infrastructure as code and SAST, it needs to be informed by what that business business's needs are. Don't try and push it further just for the sake of pushing it further. Push it to where the business needs it to be, and don't try to make it even any more complex than it really has to be, right? That's complexity for the sake of complexity is never a good idea. Complexity, it just needs to be just complex enough to meet the business needs.
Yeah, absolutely. And unfortunately, we don't have time for questions because we're at the top of the hour now. But there's a slide for if you want to talk to us and contact us more.
Man, that was great. I appreciate you guys pulling this together. Feel free, everybody, if you've got questions, please follow back up with Alex and John. We look forward to seeing you on the next webinar we have. Thank you.
Absolutely.